All right, let's just jump right in. What if I told you that a popular, trending AI skill, one that people were installing left and right, was basically designed to peek into the digital equivalent of your diary? Well, that's not a hypothetical, it's a true story, and it tells us a lot about what happens when AI tools grow way faster than the safeguards around them.
So picture this. It's just another day. A totally routine audit is running in the background, scanning the AI skills in our environment. Suddenly, this automated system, which is usually pretty quiet, starts screaming. And it's pointing at a really popular research skill, one that was all about analyzing your activity from the last 30 days. So what was the big deal? What was the flashing red light? Well, the alert was for something called NV_read activity. Now, if you're not a developer, that might sound kind of boring and technical. But in the world of security, that's like the smoke alarm going off right next to your most valuable possessions. You have to check it out immediately. And here's the thing that really made us sit up and pay attention. This wasn't some one-off mistake in a single file. We're talking 10 different hits spread across the entire package. It was in the code, the specifications, even in the documentation. When you see something like that, you know it's not a bug. It's a feature. It's part of the design.
Okay, so let's get to the heart of it. What does ENVR-read really mean, and why is it such a massive red flag? Well, it means the skill is programmed to access and read the system's environment variables.
And you need to understand, environment variables are basically a special, protected lockbox on a computer. It's the place where applications are supposed to store their most sensitive, most important data to keep it safe. It is not a public library.
And look at the kind of stuff that lives in there. We are not talking about your preferred color scheme. We're talking about the keys to the kingdom. API keys, payment processing secrets, database login info. Literally all the things a hacker would dream of getting their hands on.
Which brings us back to that pattern. When you see code that's built to snoop around in this ultra-sensitive area across 10 different files, you just have to accept it wasn't an accident. It was a conscious design choice. Now, was it malicious or just lazy coding? Honestly, at this point, the why doesn't even matter. The capability to do damage was built right in.
You know, this whole incident just shines a massive spotlight on a huge and frankly pretty dangerous misunderstanding in the AI world right now. People are treating these AI skills like they're just simple prompts, like you're just typing a question into a chat window. But they are not the same thing, not even close. Let's just break it down real simple. A prompt is just text. It's instructions. A skill, on the other hand, is code. It's an executable program. It has permissions, it can read your files, it can connect to the internet, and as we've just seen, it can try to read your secrets. They're in completely different universes.
And honestly, it all boils down to this right here. If you're a developer, you know you would never just find some random package on the internet and install it on a live server without checking it first. You just wouldn't. We have to apply that exact same level of caution to AI skills. Installing a skill is an act of trust. So this potentially dangerous skill is discovered. What happens next? Does a siren go off? Do people start running around in a panic? Nope, not at all. And this is where having the right security architecture in place makes all the difference. The response was automatic. It was instant, and it was calm. It was about one thing: containment. The first thing the system did was analyze the code and spit out a risk score. And the number it came back with? 94 out of 100. That's not a, hey, you should look at this. That is a critical alert. The system had zero doubt that this was a serious problem. And then, boom, 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 the automated response kicked in. All of this happened in less than a second. It immediately pushed the skill to the top of the list for a human to review. It slapped a big quarantined badge on it. Then, most importantly, it completely blocked the skill from running. And finally, it logged every single one of those 10 hits for the audit trail. No drama, just instant, clean, effective containment. This whole event is the perfect real-world example of a fundamental security principle. The system didn't care that this skill was trending. It didn't care about its popularity. It assumed nothing. It just verified the code, found the risk, and acted. Period. So, this is where we need to zoom out a little bit and talk about the bigger lesson here. Because this isn't just about spotting bad guys. We have to start thinking about security risk in a much more sophisticated way.
I know what you're probably thinking. Was this skill actually malicious? Was it actively trying to steal secrets and phone them home to some server? And the honest answer is, we don't know for sure. But here's the kicker. It doesn't matter.
And this is the key takeaway of this whole explainer. The problem isn't the intent, it's the capability. This skill was built, by design, with the ability to read your most private data. Whether it was using that ability for evil today is way less important than the fact that the potential for abuse was built right into its DNA.
You see, modern cybersecurity isn't about trying to guess where the next attack will come from. It's about reducing your attack surface, basically locking all the doors and windows you're not using. This skill needlessly propped open a huge window right into the most sensitive room in the house. Good security is about closing that window long before anyone even thinks about climbing through it.
Now let's pull the lens back one more time. This one incident isn't just an isolated event, it's a signpost. It tells us where we are in the evolution of AI ecosystems, and it gives us a clear roadmap for how these platforms can grow up and mature safely.
We've seen this movie before, right? With browser plugins, with mobile apps. Every new tech ecosystem goes through this life cycle. First, you have the early days. It's a wild west of innovation and rapid growth. Then you hit the mid-stage, where we start realizing, whoa, a lot of these tools have way too many permissions. That leads to the challenge phase, where you see actual attacks and data breaches. And finally, you get to maturity, where solid architecture and automated security checks become the absolute standard.
And the lesson here is so important. The solution isn't to get scared and stop innovating. It's not about paranoia. The solution is just better architecture. It's about building security into the very foundation of these platforms from the beginning, not slopping it on as an afterthought.
So I want to leave you with this idea, because it really is the guiding philosophy for building a healthy, mature AI ecosystem. Trust isn't something you just give away. It has to be earned. The ability for any code to run, to execute, has to be gated by security. And that verification process can't be manual. It has to be automated and relentless. That's how platforms grow up, and that's how this entire incredible AI ecosystem is going to scale safely for everyone.